A semiconductor material has an electrical conductivity value falling between that of a conductor, such as metallic copper, and an insulator, such as glass. Its resistivity falls as its temperature rises. Metals behave in the opposite way. Its conducting properties may be altered in useful ways by introducing impurities, doping, into the crystal structure. When two differently doped regions exist in the same crystal, a semiconductor junction is created. The behavior of charge carriers, which include electrons, ions, and electron holes, at these junctions is the basis of diodes, transistors, and most modern electronics. Some examples of semiconductors are silicon, germanium, gallium arsenide, and elements near the so-called metalloid staircase on the periodic table. Silicon is a critical element for fabricating most electronic circuits. Semiconductor devices can display a range of useful properties, such as passing current more easily in one direction than the other, showing variable resistance, and having sensitivity to light or heat. The modern understanding of the properties of a semiconductor relies on quantum physics to explain the movement of charge carriers in a crystal lattice. The semiconductor materials used in electronic devices are doped under precise conditions to control the concentration and regions of p and n-type dopants. Some of the properties of semiconductor materials were observed throughout the mid-19th and first decades of the 20th century. The first practical application of semiconductors in electronics was the 1904 development of the cat's whisker detector, a primitive semiconductor diode used in early radio receivers. Developments in quantum physics led in turn to the invention of the transistor in 1947, the integrated circuit in 1958, and the MOSFET, metal oxide semiconductor field effect transistor, in 1959. Thomas Johann Seebeck was the first to notice an effect due to semiconductors, in 1821. In 1833, Michael Faraday reported that the resistance of specimens of silver sulfide decreases when they are heated. William Grills Adams and Richard Evans Day observed the photovoltaic effect in selenium in 1876. Alexander Graham Bell used the light-sensitive property of selenium to transmit sound over a beam of light in 1880. Power rectifiers, using copper oxide and selenium, were developed in the 1920s and became commercially important as an alternative to vacuum tube rectifiers. The first semiconductor devices used galena, including German physicist Ferdinand Braun's crystal detector in 1874 and Bengali physicist Jagadish Chandra Bose's radio crystal detector in 1901. The first working transistor was a point-contact transistor invented by John Bardeen, Walter Hauser Braddon, and William Shockley at Bell Labs in 1947. Shockley had earlier theorized a field effect amplifier made from germanium and silicon, but he failed to build such a working device, before eventually using germanium to invent the point-contact transistor. In 1954, physical chemist Morris Tenenbaum fabricated the first silicon junction transistor at Bell Labs. However, early junction transistors were relatively bulky devices that were difficult to manufacture on a mass production basis, which limited them to a number of specialized applications. The U.S. Patent and Trademark Office calls the MOSFET a groundbreaking invention that transformed life and culture around the world. FinFET, Fin Field Effect Transistor, a type of 3D multi-gate MOSFET, was developed by Dig Hisamoto and his team of researchers at Hitachi Central Research Laboratory in 1989. This article is under the GNU Free Documentation License and the Creative Commons Attribution, Share Alike license. It contains excerpts from the semiconductor page on Wikipedia.